Welcome to Team 6's cornerstone project, the EEG-controlled blimp. We set out to miniaturize and modify Dr. Tane's original circuitry to present a demo that could be used by the NMSU College of Engineering Outreach Center. The mind-controlled blimp will be used as a demo for the Outreach Center as they engage with high school students to get them interested in engineering. We started this project after interviewing with Dr. Tang to see what he'd been working on. He introduced us to the EEG sensor he was using called the MindWave mobile headset. Initially, the blimp was flown by one user wearing one of these headsets. We built upon this idea by using two headsets instead of one, so that a team of students could work together to fly the blimp. The second goal of the project is to miniaturize the circuitry to fit onto a printed circuit board that would fit into packaging we would design to house electronics. Here is our hardware block diagram of the project. On the top left, we have the blimp, and on the bottom left, we have our two EEG headsets. These two blocks are separate from the circuit we designed, which is on the right of the diagram. This circuit communicates with the headset over Bluetooth and with the blimp over infrared. The base of the electronics is a modified Arduino circuit that implements two Bluetooth modules, several LEDs, two switches, and the circuitry contained in the remote controller of the blimp. The LEDs, switches, and battery are all mounted externally to the electronics packaging, and the packaging is made out of plexiglass so that the students can see the PCB inside of the packaging. Software is another important area of the project. As data from the headsets is read, the electronics decide if the brainwave levels are above a threshold value. If so, the electronics will tell the blimp to move accordingly. The first user can make the blimp dive, while the second user can make the blimp turn right. The blimp is also always climbing or going straight unless the brainwave levels are above the threshold. The two switches of the project control whether the user has to concentrate or relax to control the blimp. After the initial design process, our parts were ordered and the assembly was completed. We encountered several obstacles as we began assembly, but in the end, we were able to troubleshoot and solve each of them. Testing began soon afterwards and was completed in stages, beginning with uploading code to our board, testing Bluetooth connections, reading in data from the headsets, processing data, sending infrared commands to the blimp, and finally compiling all of these for the final test. Each step had many challenges to complete before we could move on to the next. The final consisted of two team members controlling a blimp in an indoor flight test. This project was successful, and Dr. Tang was able to see our last test flight we performed. The process of this project taught us about working in Eagle with PCB design, building design requirements, soldering, troubleshooting, and testing. Each of these skills will be very applicable to future projects because the design process of a project is very similar from one to the next. Our team especially learned the importance of getting help from other students and professors around us, and how to successfully troubleshoot a problem and be able to fix it. The EEG-controlled blimp was successful, and next semester it will be demonstrated in front of the NMSU College of Engineering Outreach Center.